Welcome to the Planet of Maths channel. In this episode, we'll talk about inequalities with absolute values. To get to inequalities, we have to start with equations, as they are related. Let's begin with an example like this. We can solve this kind of example in the following way. First, we notice the number here, but with the sign changed. I'm interested in the number 2 here. I mark this number 2 on the number line. Here we have the number 2. The solution to such an equation on the number line will be numbers that are 3 units away from this 2. First, we move to the right by 3 units. 1, 2, 3. We land here at number 5. Here, the distance is 3, so our solution will definitely be x equals 5. The number 5 fits here. But also from this number 2, at a distance of 3 units, we can find a number to the left. If we go 3 units to the left, we'll end up at this number -1. -1 is also a solution. We have 2 solutions, x equals -1 and x equals 5. We need to add that this method will only work when we only have x here. There cannot be anything in front of x. There cannot be any number. There cannot be any sign. Only in this situation this method works. We solved example A. Let's move on to example B. It will be very similar here. First, we find the number that is inside the absolute value. So this time, since there is +1 here, we are interested in the number -1. We change the sign here. -1 is here. We are looking for numbers that are 4 units away from this -1. This number tells us the distance, so we go 4 units to the right. When we do this, we end up at 3. That's our first solution. The second solution is to go 4 units to the left from this -1. 1, 2, 3, 4. Here we end up at -5. That is the second solution, x equals -5. That's how you solve equations using this method, and now we move on to inequalities. Inequalities will be quite similar. We have such an inequality. We also start from this number here with this absolute value. This time it will be the number -2. We mark this number on the number line. Such an absolute value should be read in this way. We are looking for all the numbers whose distance from that number -2 is less than 3. So first, we find when it will be equal. We want to find a distance of 3 from this number, so we go 3 to the right. We find that number. 1 is 3 units away from this -2. Here I put an open circle because we have a strict inequality. If we have a strict inequality, then these circles must be open. On the other side of the number -2, we also find a number that is 3 units away. We go 3 to the left, 1, 2, 3, and it is in this place. In these 2 spots, the distance from the point -2 is equal to 3. Here we have 3, and here we have 3. What we're interested in is for it to be less than 3. This distance from that point -2 needs to be less than 3. So, since here it is equal to 3, less than 3 will be everywhere here. The distances of these points from this number -2 are less than 3, and the same goes for the points to the left. Everywhere here is less than 3. If I went further here, it would be more than 3. So the solution will be this interval here, meaning all the numbers between -5 and 1. In interval notation, we can write it as x belonging to the interval from -5 to 1, and here we put parenthesis. In example D, we have an absolute value of x -3, and it should be less than or equal to 4. We do similarly. First, we take this number, which is 3, change its sign. The number 3 is here. We first find such numbers that are 4 away from this 3. 4 to the right is here. And this time the circle is closed because we have a non-strict inequality. Here it should be smaller or equal, so the circle is closed. Just like from this number 3, we move 4 units to the left. We'll find this number. Here too, I'll color in the circle. I want these distances to be smaller or equal to 4. Equal is here, and less than 4 is somewhere here, in all these places. So it'll be a similar cap to the previous example, from -1 to 7. Since the circles here are closed, we need to put a square bracket on this side and on this side as well. So x belongs to this interval, and this is our solution. Example E. The absolute value of x -2 needs to be greater than 2. We proceed similarly. First, we take the number 2, this time positive since we changed the sign here. Mark 2 on the number line and find numbers that are at a distance of 2 from this 2. 2 to the right is here. And an open circle because the inequality is strict. And 2 to the left of this 2, which is here, again, an open circle. In these spots, here and here, the distance from this 2 is equal to 2. But in our example, we want all numbers where the distance from this 2 is greater than 2. So, the distance from this 2 here is less than 2. Everywhere here, it is less than 2. Here, it is equal to 2. And I want it to be greater than 2, so I'm interested in all the spots somewhere here. Using an interval, we mark it this way. This interval starts from 4 and goes right towards infinity. This is the first interval. The second interval goes in the other direction. From this 2, the distance everywhere here is less than 2. In this spot, the distance is equal to 2. And I want this distance to be greater than 2, so these will now be the points. And all these points are under such a cap. This is the second interval, and in the case of example E, we have a solution in the form of 2 intervals. The first interval starts from minus infinity because it does not end anywhere to the left, but it ends here at 0. Here we put parentheses. Union with the second interval, which starts at 4 and goes to positive infinity, meaning it doesn't end. Here we put parentheses on both sides as well. If the inequality is strict, then these intervals will always be open. And the last example, we have the absolute value of x plus 1 is greater than or equal to 3. So, we take this number with the changed sign, we have -1, so we're here, and we want to find all the numbers whose distance from this -1 first is equal to 3. So we move 3 units to the right and find the number 2, put a closed circle here because the inequality is not strict, so the circle is closed. And the same way, from this -1, we go 3 units to the left, landing here. At -4 and 2, the distances from -1 are equal to 3. Here it's 3, and here it's 3. But we want it to be greater than or equal to 3. So greater than or equal to 3 will be, well, not here. From this -1, these are small distances, small, small, small. Here it's a distance of 3. But I want it to be greater than 3, so it will be somewhere here. So the interval looks like this. To the right to plus infinity, it does not end anywhere over there. And the same on the other side. From -1, these points are at a small distance. This point is exactly at a distance of 3. But I want points at a distance greater than 3. So these will be points that are somewhere here. And if I want to mark this as an interval, I do it this way. Here I have the interval where the numbers are more than 3 away from this -1, more than or equal to 3. In interval notation, we'll write it like this. Here, the interval extends endlessly to the left, so we'll write -infinity, and on the right, it ends at -4. In intervals at negative or positive infinities are always put parentheses, but at -4, the circle is closed, so the interval is closed. This is my first interval, combined with the second interval. The second interval starts at 2 and goes endlessly to the right, so it extends to positive infinity. We always put parentheses at infinities, but at 2, the circle is closed, so we put a bracket. That's how we solve this type of inequality. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Maths channel.